So my name is Ainis Laksdiņš. I represent Latvia University of Life Sciences and Technologies, and I will try to be a moderator for this workshop. You are very welcome to the workshop on catalogs of measures supporting multiple ecosystem services. And this workshop is a part of a series of workshops organized by the WaterDrive project on water management in agricultural landscapes. And this particular workshop is a part of work package 3 and group of activity 3.1. I can see that there are many participants who participated also in the first session, in the morning session of workshop, where we talked about geospatial data and its usability in water management. So we would like to continue this topic by paying more detailed attention on a catalog of measures which is elaborated in the WaterDrive project. Overall, we are having 8 presentations today prepared, and in between the presentations, we will have a group discussion on in the breakout room where we will be separated to 4 to 5 persons in each group. And I will post a question that we suggest to discuss in these separate rooms. And then at the end, we will have a discussion part for those questions that you have, and maybe for those concerns that you would like to address as well. And yes, I would like to give the word to Katarina Kilmar on her presentation about the introduction to catalog of measures and need for information on measures. So Katarina, the floor is yours.
Thank you, Ainis. I should just adjust here. Well, yes, as Ainis said, we have had the task, have a task in WaterDrive that is about collecting information about measures made around the Baltic Sea, measures against nutrient losses and for water retention. And today, or I should say, when we have worked with this, with collecting information on measures, we have divided them into where they are made, like on the field, between the field and stream, in the stream, or in the whole catchment. And altogether, we have collected information about 12 measures. And today we will hear presentations for 6 of these measures. Those are indicated in red here. And if we look at measures, it's not only, it's many aspects when you look at the measures. First of all, it's the effect on nutrient leaching and water retention. And that, of course, that varies largely among the countries and also within the countries, and depending on the soils and the water, the hydrology, the climate, and how the land is used. And then if we look at, we also have side effects. So maybe a measure that is positive for phosphorus reduction is negative for nitrogen. And then we have all the benefits that's so important today. We have to look at how a measure works in other aspects than nutrient leaching. It's like this with climate mitigation and for production and for reducing the risk for drought and flooding and so on. And then, of course, we have the cost, and that's in long term and in short term. And where to localize the measure, because it's the efficiency varies largely. And then we have the implementation, how do we implement the measure in the best way so it get the effect we want. And then we have other experiences to share on the measures. So it's a lot of things. And we have made a catalog on the web. It's still not filled in with all measures, but all measures are described in separate documents. So they should just be included in this catalog. And for example, how each measures are described. So they are described shortly first, and there is how they works in functionality and efficiency, where they are best localized, and also the duration and maintenance of the measure. And we also have information and links to other sources, and we also have more information in these websites on each measure. And then we have tried to attempt the effects on other effects than just nutrient retention, like groundwater infiltration, how the measure works in regard to productivity, biodiversity, carbon storage, greenhouse gas reduction, and so on. So this is not the exact science, it's more like an attempt to estimate. And this is an example for structural liming, and here we have said for 1 year ago that the nitrogen retention is not relevant, but new knowledge has, from experiments, we know that the nitrogen retention, or we can have a risk for increased nitrogen leaching when we do structural liming. So that are all my pictures. So then I think we could start with the first presentation. That is Pasi from Psyke, that will talk about the gypsum amendment for reduced erosion and losses of phosphorus.
Katarina, I would like to propose that my colleague Linda Grinberga would present first, as she has unexpected personal reasons to leave earlier than we thought. So for that, as I understood, Pasi and also Eduard agreed to give a floor first to Linda. So Linda, please, you can share your presentation on on-farm treatment of stormwater in subsurface flow constructed wetlands. Please.
Hello, everyone. Thank you for letting me present my topic a little bit earlier. So I hope that you can see my presentation and everything is fine with that. So the topic for me today is on-farm treatment of stormwater in subsurface flow constructed wetlands. If we talk about the agricultural impact on the environment, about the nutrient leaching, about suspended solids, then in most cases we talk more about and we think more about agricultural fields. But in this presentation, I would like to outline other agricultural areas and I'm talking about farmyards, about the hard surfaces, and about areas where some equipment is stored and where maybe some cattle is moving and living and so on. So there are a lot of areas which we can consider as a small area, not very huge area usually, which is with the hard surfaces and hard pavements. And usually we talk more about the stormwater in that kind of areas instead of agricultural runoff, for example, as it is in agricultural areas. So we should consider the measure that is more close, maybe even to rural areas, and maybe even with the content that is of the water that is even sometimes close to the domestic sewage waters. And so let me show you firstly in my presentation there is just the content. I will introduce you to the measure that is subsurface flow constructed wetland that can be used to treat that kind of water. Then the next point I will tell very shortly about the study site in Latvia that we have, and we have built such subsurface flow constructed wetland and monitored it already for 7 years, and we can say how it works in Latvian conditions. And then there is the third part is shortly about ecosystem services that is provided by this kind of measure, and some further research and ideas that I would like to present now. Subsurface flow constructed wetland, if we build it as a main idea and the main purpose of building and designing that kind of measure, this is for water quality improvement, then we can consider it as a biological wastewater treatment system. It can be used to retain nutrients, to move organic matter, and that's how we improve water quality. And anyway, this is a nature-based treatment process, and it should be adapted to the specific water that we have to treat. And depending on the water quality and water amount that we have and that we have to treat, we can make a difference in designing in dimensions and technical solution of this specific subsurface flow constructed wetland. In the picture you can see two main kinds of or technical solutions of subsurface flow constructed wetland, but the idea is that water flows slowly or filtrates through the filter material, through porous media, and in above there is a vegetation planted, and due to this slow movement horizontally or vertically through the filter material, the bacteria that are living in this porous media, in the combination of positive effects of plants and plant roots, the bacteria is biologically treating the water, or mainly it's retaining retaining nutrients and organic matter. Of course, there can be different solutions depending on if we want to achieve more aerobic or more anaerobic conditions, and we can adapt it basing on the water that we have at the inflow. Yes, next is some pictures of my study site, of our study site in Latvia, in the middle part of the country. There is stormwater collected from hard surfaces. In the farmyard, there are some greenhouses and equipment stored periodically, and so on. So all the rainwater is collected, and then water flows firstly in an open storage basin. You can see the picture in the springtime and in the wintertime. So you can see how it looks like just visually. The basin first, before the wetland is made, to make the water flow as possibly even, so the wetland can perform more regularly. And here where the reeds are, in the picture where the reeds are, you can see this is the subsurface flow constructed wetland. If we look like more schematically on that, then yes, you can see some areas, and basically the surface area of subsurface flow constructed wetland is pretty much related to retention time that is very important for bacteria to make all the transformations with nitrogen, to filtrate all the material and to treat the water, basically. Yes, and once again, some picture of our research site in Latvia. Yes, and now some numbers just to prove that it works pretty good. And the first question was if it works good enough during the winter time. And you can see those reduction numbers now, and inflow and outflow concentrations for different parameters that we have measured for 7 years. So you can see that the inflow concentrations are high enough, and reduction percentage is very promising. Yes, and the next pictures show very interesting numbers of BOD and COD, because usually, let me go back a little bit, usually when we measure and try to evaluate the agricultural runoff, we usually stick to nitrogen, phosphorus, and suspended solids. But as I mentioned at the very beginning, sometimes this water that has to be treated from different kind of agricultural areas, sometimes it contains even more organics that we can expect. And it was like that in this case, and it was really interesting. I started to take samples and analyze BOD and COD in the inflowing and outflowing water, and I discovered that this water is pretty much close at the periods, pretty much close in the concentrations as it is with domestic sewage water. That's why it's really good that I have impermeable layer at the bottom of the wetland, so I don't pollute groundwater, so it's not connected with the groundwaters. And yes, and the efficiency for BOD and COD, you can see it's pretty much good. So the wetland works really effectively in treating the water. If we look at different kind of parameters that we can measure, and here you can see quite similar picture with nice effectiveness in COD. So you can see that the inflow water is really really high concentrated with different organic matter, and at the outflow the water is pretty much more treated.
Linda, I'm sorry to interrupt you, but you are almost used all the 10 minutes that we have suggested for the presentation. So please try to be consistent and
Yes.
and try to finish in 2 minutes approximately.
Okay, great. I will try to do it. So retention for BOD and COD, as you understand, it's really high, close to 90%, and I'm really happy with that. Okay, so if we are moving very fastly forward, then in that kind of areas which are agricultural ones, then there are different other other good things that we can add besides of treating the water or improving the water quality. And in this specific study site that we have, we can see that you can use different services, ecosystem services that provides this kind of measure. And it can be used. The main thing is increasing the biodiversity. If we don't divide it in 3 categories or something, but just say the main thing, then the biodiversity, increased biodiversity, I think it's the main thing besides of water quality improvement. And you can add different other options, different other services to that kind of measure when it's built in the middle of agricultural areas. And yes, and to finish very fastly, then you can see some average percentage, which are really promising. And I would like to add just that constructed wetland as it is, it's actually as a biological waste or the treatment system. And depending on what kind of water do we have to treat and in what amount it is, depending on those 2 parameters, we can calculate and design different technologically different constructed wetlands. And we just decide if we need to provide aerobic or anaerobic conditions. We decide about retention time, and we can build a very effective measure to treat the water. So that would be it for this topic. Thank you.
Thank you, Linda, for your presentation. So we have a few questions. So as you have to leave, maybe we can address those. So the first one is, did you quantify ecosystem services for this measure?
No.
Short answer is no, but
no, yeah, it's very shortly, of course, but yes.
It can be a topic that we can still expand our existing studies.
Definitely.
And then the next question from Daniel is, what is the retention time?
Yeah, it depends on water quality, what comes in. If it's, it can last from a few days, few hours to few days, I would say. Because if we have like clean water coming in and you have to remove only like suspended solids, then it's only a question about the filtration rate of the porous media. But if you have to provide like a proper conditions for the bacteria, then yes, you have to calculate the retention time appropriate to the bacteria that you want to work.
Okay, and the last question from Christina, have you estimated maintenance costs?
Yes, the maintenance actually is very easy, because the main thing that you have to do is you have to cut the reeds regularly once per year during the springtime. And the other thing is that you have to, if you have a pump, then yes, then you have to check if it works properly, and if no, then you have to repair it. But usually, if there is good conditions of relief of slopes, then possibly you can even not put the pump at all and do it with the self plow. So basically, yes, 2 things. And of course, you have to check if some other things, like if it's subsurface low constructed wetland, then you have to check if you don't see any surface water in above, then you can know that it doesn't work good in that case.
Okay, thank you, Linda, for your presentation, and thank you also participants for your questions, but we have to move further. And I would like to give a word to Pasi Valkama from Finnish Environment Institute, and he will talk about the gypsum amendment for reduced erosion and losses of phosphorus. So Pasi, the floor is yours.
Thank you. I hope you can hear me and see my presentation at the moment.
Yes.
Okay, excellent. So the topic for me is gypsum amendment for reduced erosion and losses of phosphorus. And thank you for this opportunity to tell you something more about gypsum, which is maybe some kind of Finnish specialty for water protection use. Okay. Here are some photos of our first study site before gypsum was used there. And as we know, the phosphorus loading from agricultural fields is the largest threat to water quality and marine living resources in many Baltic Sea countries. And one especially severe case is that this over-fertilization, which has been going on in Finland, for example, has accumulated the phosphorus to fields very high amounts, and this so-called legacy phosphorus and the amount of the phosphorus, it takes decades to lower again, even if we ended all the fertilization at the moment. So that's why we need some methods which we can achieve immediate and fast responses to lower the phosphorus load. About these photos, I don't know if you can see my pointer here, but as we can see, especially outside the growing season in Finland, there may be very severe erosion events, especially after the snow melting period. And phosphorus, suspended solids, and also carbon is released and flushed away from these kind of fields. And the water flows onwards from fields to ditches and then again to larger rivers, and it ends up to the Baltic Sea. Okay, but we have luckily some measures that we can achieve fast responses to lower the phosphorus fluxes, and gypsum calcium sulfate is one of these measures, and it has been long known to improve the soil structure in fields. And there is, I would say, maybe some hundreds of years of history of gypsum used in agriculture as a fertilizer, for example, as a sulfur and calcium fertilizer. But it has very high potential to reduce erosion, particulate phosphorus, and also dissolved reactive phosphorus, which is algae available immediately. And in Finland, we have studied the impacts of gypsum, especially in clay field areas, because according to theory, that's where the gypsum would work best. But we have got some interesting result also that gypsum may reduce also the fluxes of organic carbon. There are many sources of gypsum, and one of the major and most important source and form of gypsum is this so-called phosphogypsum, which is the byproduct of the production of phosphorus acid. And there is in central Finland, there is this one maybe largest open apatite mine from where the apatite is mined, and then this phosphorus is separated from this mineral with the aim of sulfuric acid. But there is also other sources, for example, from industry and power plants, there's flue gas desulfurization, gypsum, and of course the recycled gypsum. For example, in gypsum boards used widely in construction, they may be used also recycled gypsum source. And then of course the natural mined gypsum. Here's actually a photo of this natural formed gypsum, and this is phosphogypsum. And this natural gypsum can be used in Finland also in organic fields. Those other sources are not allowed to use there. But how does gypsum work when we add it to the field? The suggested amount at the moment is 4 tons per hectare. That has been adjusted. The amount has been adjusted on the basis of first laboratory result. But when we add gypsum to fields, it is very easily soluble, and actually it's over 2,000 times more soluble than the normal carbon-based lime products. And when it's solutes to the soil, then the ionic strength is increased very quickly and highly, and that causes the clay particles they can form larger aggregates. They get closer each other, and then they also bind the phosphorus a bit more tight to them. And here are some pictures of this same study site as the previous pictures. Here's a field pond with no gypsum, and here is a field treated with gypsum. And as you can see, the water standing in the pond of this field is very clear. And we have also simulated, especially for farmers, we have used this simple kind of rainfall simulation. We have a box with 2 soil samples with no gypsum as a reference sample, and then another soil sample where we have added a gypsum. And then we simulate the rainfall and collect the infiltrated water. And as you can see, the result, the change in water color and clarification is really clear and immediate. Gypsum is very easy to apply measure. Farmers can use a lime or manure spreader to spread gypsum. And as I told you, the suggested amount is 4 tons per hectare. And with that amount, we can achieve those phosphorus load reductions. And in Finnish studies, the average reduction of particulate pound phosphorus is about 50%, and for DRP, dissolved radioactive phosphorus, about 25 to 30%. And also to DOC, dissolved organic carbon, there is about 30 to 50% reduction achieved. Okay, about ecosystem services achieved with gypsum. Of course, when there is lower phosphorus load, there is also impact on eutrophication in the sea areas in Baltic Sea. But this lower erosion rates, it has an impact also, for example, on fish breeding, for example, trout breeding, and this most vulnerable phase of trout life cycle is this egg phase, when after spawning, when the eggs are they are in the bottom of river or stream, and if there is high erosion rates above this area, breeding area, then this eggs are they are suffering for anoxic conditions, and they are not survived. So there is a clear advantage achieved with gypsum with the lower erosion rates. But then there is also interesting benefit for farmers, which have to maintain the drainage ditches. And of course, when there is less sediment and suspended solids flushed away from fields, then the drainage ditches are not that easily and fast. The sediment is not accumulated, and the drainage capacity is still maintained. And also the lower carbon fluxes achieved with gypsum, it has this carbon storage impact and so on, the climate change mitigation effect. There are still some gaps.
I'm sorry to interrupt you, but you also have used all the 10 minutes for the presentation. Okay. So maybe you could summarize your presentation and leave time for one or two urgent questions.
Okay, this is actually my second last slide, but if I go quickly through these gaps of knowledge, and there is some preliminary results that gypsum may have impact also in organic and coarser mineral soils, but this has to be studied more closely. And the duration of the impact and optimal dose in different conditions is one gap of knowledge also. Okay. Yes, well, that's all, and thank you for your attention. I'd like to advertise and one upcoming event. There is in next week interesting webinar arranged in the project called Gypsum Initiative, and there is a bit more detailed information about gypsum research. Thank you.
Okay, thank you, Pasi, for your presentation. And yes, we have a question from Ernst that you basically replied already. For how many years does the application of 4 tons per hectare of gypsum last?
Yes, well, in our studies, it's about 5 years. The impact has been found to last 5 years, and then it should be repeated, or then maybe we have some extra time to lower that legacy phosphorus contents of fields with the aid of gypsum. 5 years approximately.
Okay, thank you. Thank you, Pasi. And so with this, we could move to the next presentation. By the way, Pasi, I'm registered to the webinar you promoted in your last slide, so we might meet there.
Okay.
So yeah, the next presentation will be given by Eduard Vasiliev from Federal Scientific Agri-Engineering Center, Wim, from St. Petersburg, Russia. And the topic is, as you may see, in furrow subsoil application of a liquid organic fertilizer under pressure. Dear presenters, I would like to remind you based on previous two presentations, that the time for the presentation is approximately 10 minutes. And I know that we have been using a lot of time and effort to make this study possible, and we would like to talk about at least half an hour, but in this case it is not possible. Therefore, please try to fit in your presentation within 10 minutes. Thank you. Edward, the floor is yours.
Thank you. I hope you can see my presentation.
Yes, it works good.
Okay. Thank you for opportunity to show my presentation, and today I want to show you just general information about this measure. And inflow subsoil application of liquid organic manure-based fertilizer under pressure is a manure emitted to reducing the time of contact between fertilizer and the open air, and immediately spread into a root zone without the flow layer. The spread of fertilizer within the soil helps accelerate its infiltration and binding of nutrients through microbiological processes. This substantially reduce the risk of the surface runoff to groundwater and surface water bodies, while cutting gas emission like ammonia and to the atmosphere. Restraints include high stones of soil, since stone can damage the implements, and filled with steep slopes, which can topple the application equipment. Moreover, when slopes are steep, liquid organic fertilizer will not get absorbed through the soil fast enough, leading to surface runoff. Natural and climatic restraints are as follows: sub-zero or temperature, since the fertilizer can freeze, and high solar radiation, since the fertilizer can irradiate to a greater extent than seep through the soil, which increases emission to atmosphere, abundant rainfall, and water-logged soil, since the speed of infiltration of liquid fertilizer goes down, and they can drain away to water bodies together with rainwater. The implementation used from the furrow commonly include a disc or one or two different type of cultivator. In the picture, you can see some manure application processing on these four pictures. Effects: faster nutrients uptake by plant and soil, coupled with the prevention of surface runoff, reducing nitrogen emission and escape of phosphorus into water bodies. The main potential of subsoil application is enhancing capability and cutting emission. Major investment costs for implementation of this method are related to the pitches of tractor and fertilizer application machine, depending on the manufacturer performance and lifting capacity of the type of the implementation used. Average until prices in Russia vary from Euro 25,000 to 130,000 and higher. The mean service life established by the manufacturer is up to 10 years, and annual expenses generally compress operation expenses, notably on repair and maintenance of equipment and salary, fuel, etc. And it's general information. That's all.
Okay, thank you, Edward. Does anyone have any questions for Edward? I can see there are no questions yet in the chat, but maybe anyone would like to pose a question now.
Maybe I can ask one question. Thank you for the presentation. Is this method very popular in your country, or is it a new one? Is it used lastly?
I think it's not so useful in our country last time to start to use this method more and more times, because after manure spreading, we have one problem with smell. And this method, as shows the experience, can reduce this part, can reduce smell. And now more and more farmers start to use this method.
Thank you. Maybe there are more questions. If no, then I would like to ask one question myself. Have you carried out any studies on what is the effect of this measure on nutrient losses in terms of surface runoff, like broad spreading versus this in-furrow subsoil application on surface runoff and also on drainage water quality?
Maybe 2 years ago, we studied how the manure spreading methods to influence for air emission we studied. But next year, and more, maybe 2 years ago, we want to start to study how this method can influence of the water quality, because now we have good contact with farmer who bought 2 new machines for these different applications, and we can to compare this method.
Okay, yeah, that would be very interesting for me to take a look at the results of such a study. So thank you. Katerina, do you have any questions or comments? No? Okay, thank you, Eduard. So then we are moving to the next presentation, which will be given by Jāna Uusi-Kampa. I'm sorry if I pronounced your name and last name not correctly. It's not so regular for me. And yes, Jāna will give us a presentation about buffer zones along water courses. And Jāna represents Natural Resources Institute, Finland. So the floor is yours. Thank you.
Thank you. Can you hear me, or can you see my presentation? Hello.
Yes, we can see now the first slide of your presentation.
But I can't see. Okay. But if you can see it, so I have my own presentation here. Okay. Thank you. I'm going to say a few words about buffer zones along watercourses. And on the second slide, I have some photos where you can see different kind of runoff events in summertime. These photos are in the beginning of June in 1995, when we had a really wet summer and had this kind of surface runoffs. And after that, we have had sometimes this kind runoff events. On the third slide, I'm going to show how a what we can do to decrease this kind of surface runoff and what effects it has on water courses. It is most important to do the right things in the field, but now I'm telling about what we can do near the ditches or water courses. And I would recommend at least one wide headlands along the main ditches to keep the soil on the field and improve the ditch. And when it would be good established about 3-meter wide buffer strips along water courses. What is the minimum, I would say? The buffer zone is a bigger one, and it is needed on the longer and steeper or more erodibility slopes. And there's also these concentrated water flows like we see on the second slide, and we could decrease this kind of erosion things by establishing grass-seed waterways on these places. When we can go on, and there are the benefits of buffer zones, and you have already seen that they prevent soil. They are along the water courses, so they prevent soil tillage and fertilization and manure use near surface water, because it's not possible to do these things on these buffers. And the permanent vegetation on these buffer zones controls erosion in sloped areas. And the buffers also increase infiltration of water into deeper soil layers. They also decrease water flow from field to surface water and remove soil particles, nutrients, and other pollutants like pesticides from the surface runoff. Carbon sequestration is also a very important thing. They also decrease greenhouse gas emissions. And don't forget increasing biodiversity in water and on land. And they improve landscape. And we can go on. There are some weaknesses and threats of buffer zones. When we have that buffer zone for a longer time in the same place, phosphorus sorption capacity of soil may decrease over time, and after that the phosphorus removal will also decrease. Retention of dissolved reactive phosphorus may be poor in some cases, and this may happen especially during freezing and thawing events in springtime, when phosphorus is liberated from the dead plant material of buffer zones. And then there's a spread of weeds, pests, and plant diseases from these buffer zones, that they would go to the field area as well. And the trees which may grow on the buffers may shade crops and where roots may penetrate to the drain pipes. And of course, there's a reduction of agricultural land, which decrease the income of the farmer. And when I may show you experimental site, that is a Lintupaju experimental field in Jokioinen area. There's a 6 plot, and we have studied where using 10-meter wide grass buffer strips, which are mown every year. And when there's a vegetated buffer strips, there is growing bushes and trees, and they are unmanaged. So we can control and measure the surface runoff from each plot and compare the results of analysis to the plot where we don't have any buffer zone, that is so-called no buffer strip plot. And we have had 4 different kinds of experiments in that field. We have studied autumn plowing and sowing in spring cereals. Then we had for a few years grazing experiment, and since 2006 till this year we studied no tillage, and with autumn we added pulp and paper mill sludge on the field area, and we can check how these buffer zones reduce nutrient losses and total solids and carbon losses from the field area. And if you want to see a few results, there's how particle phosphorus and dissolved reactive phosphorus has been decreased on the Lintupaju field. During plowing experiment, the reduction of particle phosphorus was over 40%. And during grazing, there was hardly any decrease by buffers because there was grass growing on the field area also. And if you check the direct drilling years, so you see that there was a small reduction in particle phosphorus by buffer zones. And the thing was different with dissolved reactive phosphorus. During plowing, vegetated buffer zone where we didn't manage that buffer at all, so the grass was growing there, the dissolved reactive phosphorus load increased. And this also happened during grazing years. The buffers did decrease the load, but the total load of dissolved reactive phosphorus during grazing was higher than in other experiments. I mean, compared to plowing or direct drilling. And that was really the reason that there was grass growing on the field, and some dissolved reactive phosphorus was liberated from the grass that was dying in the springtime. I think that this was all this time. I want to thank you. Thank you for the listening.
Okay, thank you, Jana, for your presentation. Do we have any questions to ask Jana? Please, Sirka.
Yes, thank you, Jana. I would like to ask two questions. The first one is, it's a little bit unclear for me, how did you ended up to recommend this 3 meter wide buffer zone? And the other one is that you said these weaknesses and threats, and I would like to know which are the most common ones. Which do you consider are the common ones? You had a list of weaknesses.
Okay, but 3 meter is from the policy of the Finnish agri-environment program that was earlier like that 3 meter wide was suggested, and I think that it looked quite good. But maybe in some cases it might be a little bit wider or less, but however, there's needed at least some area, some kind of buffer strip. And when you ask about these threats and what is the most, I would say that retention of dissolved reactive phosphorus may be poor, so they don't work very well in boreal climate. I would say that that is the most important one, and they don't maybe work very well in springtime when there's a grass is not good one.
Yeah. Okay, thank you.
Yep, thank you both. Maybe there are any other questions? Actually, I would like to ask a short question by myself. Do you agree to the statement that buffer strips mainly work for capturing phosphorus, particulate phosphorus, and ammonia, nitrogen, and that it doesn't work too much for dissolved forms of nitrogen and phosphorus?
They work quite well for particle phosphorus, but about nitrogen, ammonium nitrogen, we haven't had very high concentrations of nitrate nitrogen in our study, and I think that has not been the main problem in this study, in this experiment. So I'm not, I cannot say, sorry. I should have read about that a little bit more.
Okay, thank you. I just wanted to comment that it is very nice that you have also in your presentation showed the article where we can read more, and I will certainly look for that article afterwards. So thank you for that. Okay, if there are no other questions, so then we can go to the part of our workshop where we have a discussion in break rooms. And as now I'm posing a question that we could address during the breakout rooms. So the question is that we could discuss in the groups of 4 to 5 persons is have measures potential to deliver multiple ecosystem services. What are your thoughts on this question? And you will be divided into smaller groups, and we will come back to the joint session in approximately 10 minutes. It seems like we are back, and so the next presentation will be given by Irina Popova from the administration of Guryevsk City District from Kaliningrad region, Russia. And the topic of her presentation will be subsidy system for reclamation and restoring of agricultural lands. So please, Irina, the floor is yours.
Ну, я всех приветствую и прошу Сандиса запустить презентацию. Next slide, пожалуйста. Please.
Next slide, please.
Ну, несколько слов об особенностях мелиоративной системы нашей Калининградской области. Как правило, наша область находится в зоне повышенного увлажнения, и 70% польдеров, всех польдеров, которые находятся на территории Калининградской области, это составляет большую часть польдеров на территории всей России.
The territory of the Kaliningrad region is located in the zone of overhydration, and 70% of all Russian polders are in Kaliningrad.
Территория, которая занимает польдерные земли на территории Калининградского, составляет 98 тысяч гектаров.
The area covered by polders is 98,000 hectares.
На этой территории проживает более 90 тысяч, на этой территории находится более 90 населенных пунктов и проживает 80 тысяч населения.
With over 90 settlements, with about 80,000 people living in the polder area.
Большая часть польдеров располагается в 3 муниципалитетах, один из которых является Гурьевск.
Most of the polders are in 3 Kaliningrad municipalities, with Guryevsk being one of the 3.
Но польдерная система достаточно сложная. На каждый километр пашни приходится 1,5 километра дренажных каналов.
The polder area is densely drained. Within 1 square kilometer, there are about 1.5 kilometers of drainage channels.
Next slide, please. Основная система мелиоративная, которая включает систему мелиорации, состоит из 114 насосных станций, 1700 километров защитных дамб и 13 тысяч километров магистральных и дренажных каналов.
The regional land melioration system includes 114 pumping stations, 1,700 kilometers of water protection dams, and over 13,000 kilometers of receiving water bodies and main ditches.
Общая длина всех каналов составляет более 26 тысяч километров.
And the total length of the draining channels is over 26,000 kilometers.
Общая длина закрытой сети составляет более 420 тысяч километров.
And the closed drainage network is almost 420,000 kilometers long.
Это самая плотная мелиоративная сеть в Европе.
Which makes the Kaliningrad regional amelioration, land amelioration network the densest in Europe.
Следующий слайд кратко показать. И его можно пропустить и перейти к следующему, потому что основные показатели я уже сказала. Да. Я хочу сказать, что основная поддержка для восстановления мелиоративной сети нашей Калининградской области исходит из 2 источников финансирования. Это федеральный бюджет и региональный бюджет.
The 2 main sources of land reclamation works are the federal budget and the regional one.
Федеральный бюджет финансируется за счет программы, целевой программы развития водохозяйственного комплекса, рассчитана до 2020 года, но сейчас она продлена до 30 года, и называется она «Вода России».
The federal funding comes from the program, which was initially planned till 2020, but it has been extended till 2030, and it's dedicated to the development of the water sector in the Russian Federation.
И эта программа курируется Министерством природных ресурсов Российской Федерации.
And this program is supervised by the Ministry of Natural Resources of the Russian Federation.
И является практическим инструментом для стратегии, водной стратегии Российской Федерации.
And is a practical instrument for implementing the Russia's strategy in water management.
Региональный бюджет как раз в рамках регионального бюджета финансируется в рамках программы развития водохозяйственного комплекса Калининградской области. И рассчитана эта программа до 2025 года. Она состоит еще из 3 подпрограмм, одна из которых как раз уделяет большое внимание восстановлению мелиоративной сети.
The regional funding comes from the program called Development of Agriculture, which covers the period from 2014 till 2025. It has 3 sub-programs, one of which is dedicated to the development of agricultural land reclamation.
И в рамках этой программы осуществляется прямое финансирование региональных объектов мелиоративной системы, так как у нас делятся объекты на федеральные и региональные, и поэтому они финансируются из 2 разных источников. И в том числе в эту же программу входит субсидирование фермеров.
As soon as land amelioration facilities are of the 2 types of subordination. Some have the federal subordination and others belong to the regional authorities. The funding comes from either the federal or the regional budget, and subsidies to the farmers are funded by the regional budget.
Ну, получается так, что федеральную программу у нас представляет и федеральную структуру представляет Калининградный ревводхоз, который является ассоциированным партнером нашего проекта. А региональную структуру в рамках, значит, восстановления системы в 2019 году была создана специальная структура Калининград мелиорации, и которая отвечает как раз за восстановление объектов региональных.
As soon as there are 2 funding sources, the federal budget and the regional budget, there are 2 institutions responsible for conducting the land reclamation works. One of them, Kaliningrad Meliovodhoz, which is the associated partner of the WaterDrive project, is the regional department of the federal authority. Of the federal state budgetary institution of land reclamation and agricultural water supply, and the regional projects, the regional facilities of the land amelioration system are funded from the regional budget. And the works are conducted by the organization of the regional subordination, part of the regional government, which was established in 2019.
Next slide. Тут я остановлюсь на нескольких моментах по поводу именно субсидирования, механизма субсидирования фермерских хозяйств. Как правило, этот механизм очень четко и грамотно описан именно в региональной программе.
And now a few words about subsidies assigned to the farmers, which are part of the regional funding program.
И в рамках этой программы осуществляется возмещение расходов, ну, по 4 направлениям действует эта программа, и осуществляется возмещение расходов на восстановление общей культуры, технических мероприятий всевозможных до 60%, восстановление, известкование и снижение кислотности почвы до 90%, Также субсидии выделяются на восстановление дренажной системы до 50% и на реконструкцию гидротехнических сооружений до 70%.
And there are 4 types of measures that can be subsidized. The first type are crop-related measures, where up to 60% of farmers' costs could be covered by the regional budget. The second type of measures are measures related to liming, where up to 90% of all the costs can be covered. The third type of measures is about repairing of open ditches and closed drainage, up to 50% of costs. And the fourth type of measures that can be subsidized are related to irrigation and drainage activities.
Next slide. Так как большое внимание у нас уделяется сельскому хозяйству, и мелиорация является поддерживающей структурой этого сельского хозяйства, то осушение земли стоит у нас на первом месте. И за последнее время осушено 257 тысяч гектар, более 257 тысяч гектар земли. И кроме того, за последнее время, именно за последний год, проведена именно синхронизация федеральных, региональных и частных проектов для того, чтобы можно было эффективно использовать их в работе.
Agriculture is one of the leading sectors of regional economy, where land reclamation is one of the main types of activities. A focal point for the regional government, and as a result, the area drained in the last period exceeds 257,000 hectares. And another task of implementing land amelioration measures is to synchronize the 3 different sources of funding: federal, regional, and private ones.
Next slide. Как раз вот то, что касается синхронизации разных проектов, за последний год, например, фермеру выделяется какая-то, он берет в аренду землю, вот один из фермеров 3,5 тысячи гектаров взял в аренду землю.
There are some good results of this synchronization of different sources of funding. One company rented 3,500 hectares of land.
И на этом участке были осуществлены работы как финансированы из федерального бюджета, из регионального бюджета и частных фермеров.
And undertook measures to improve the drainage system within this area using the 3 different funds, the 3 different sources of funding.
И благодаря этой кооперации в оборот, в сельскохозяйственный оборот было возвращено 3,5 тысячи гектаров.
And as a result of these activities, 3,500 hectares of land which was previously unused was brought back into agricultural production.
Также в 2020 году, опять-таки, были восстановлены и улучшены земли за счет снижения кислотности, внесения и дискования.
2,200 hectares of land were improved due to liming measures.
И культурно-технические мероприятия было тоже в рамках этих мероприятий, это очистка территории от загрязнений и других, там более мелко шрифтом написано, я думаю, потом прочитайте. Более 2,5 тысяч гектаров.
And crop-related measures allowed to improve the status of farmland in the area of 2,400 hectares. And the types of measures attributed to crop-related ones are listed in a smaller font on the right-hand side.
Next slide, please. Также в 2020 году было улучшено за счет культурно-технических мероприятий 444 километра ирригационных каналов.
And here there are more figures about results of eco-agricultural measures undertaken in 2020.
Восстановлена система подземного дренажа на территории 87 гектаров.
Over 443 kilometers of inner farm irrigation and drainage ditches were repaired. Over 87 closed drainage network in the area of 87 hectares was reconstructed.
На территории 174 километра были восстановлены дамбы, а также реконструированы 8 насосных станций.
174 kilometers of dams were restored and 8 pumping stations were rehabilitated.
Это все позволило возвратить в жизнь 60 тысяч гектар.
And it allowed to improve land melioration status in the area of 60,000 hectares.
Next slide, пожалуйста. В 2021 году вот те же самые мероприятия, я не буду перечислять эти цифры, благодаря этим мероприятиям возвращено и восстановлено 40 тысяч гектаров.
And in 2021, thanks to similar measures, over 40,000 hectares improved their status.
Next slide, please. Ну и хочу сказать, что все эти мероприятия приводят, соответственно, к повышению урожайности. Если говорить о том, что вот сейчас цифры, которые вы видите, благодаря этому Калининградская область находится в числе 5 регионов России по урожайности сельскохозяйственных культур.
And as a result of these measures, yields in the region increased significantly. And today, Kaliningrad region is one of the 5 best Russian regions with the results with regard to the yields of the listed crops.
На слайде приведены как раз урожайность зерновых, рапса и сои с гектара. Но эти показатели превышают почти в 2 раза среднероссийские.
And the Kaliningrad regional yield rates are nearly 2 times as high as the average rates in the Russian Federation with regard to rapeseed and soybeans in particular.
Спасибо за внимание. Собственно говоря, все.
Thanks for listening. This is what I wanted to tell you.
And thank you also for translation. So, Katerina, would you like to raise your question?
Yes, I put it in the chat also, but I was interested if there is dedicated any money for the monitoring of the effects in the waters, the water quality aspects.
Вообще мониторингом у нас занимается структура северо-западного, специальная структура, которая создана у нас в регионе. И эти деньги выделяются из бюджета. Мониторинг проводится. Да, федерального и регионального бюджета.
Water monitoring is implemented by a regional department of the Northwest District institution dealing with water monitoring activities, and money is allocated from the federal and regional budgets.
Мониторинг проводится как по снижению кислотности почвы и внесению известкования, так и по заволачиванию территории для того, чтобы определить, какой процент необходимо возвратить опять в сельскохозяйственный оборот.
And the regular monitoring program includes water quality in projects related to structural liming. And another regular monitoring done is related to the flood status of agricultural land. And it's aimed at estimating the areas that need to be brought back into agricultural production.
И вот благодаря этому уже сейчас запланирована эта программа до 2025 года, и эти деньги предусмотрены как в федеральном, так и в региональном бюджете на восстановление еще большей частью насосных станций, потому что Без них у нас работать мелиоративная система не может.
The monitoring program is, so money for the monitoring program has been assigned till 2025. And another subject which is regularly monitored is the effect on the water quality, the effect posed by the pumping stations, because pumping stations are a very essential facility of the drainage network of the region.
Yeah, thank you. That was very good to hear, and I will very much look forward for the results when they come.
Okay, thank you. Ernst posed in the chat room comment. Ernst, would you like to say something also? Because some part of the question was kind of answered by Irina. Please.
Yeah, I can perhaps then restrict it perhaps to the last 2 points that I brought up there in the chat. I mean, are you considering or looking at the effects on biodiversity? I see on the pictures you have a lot of what looks like wetland or potential wetland areas that you are draining now. I mean, in Sweden and other countries, I mean, many wetlands are being restored, the reverse of what you're doing in order, for example, to improve biodiversity. Another issue is that I believe many of the soils that are being drained in your area are organic soils. We have problems with drained organic soils that emit large amounts of greenhouse gas and carbon dioxide and also shrink as a result of decomposition. Is that an issue that you're looking into as well?
Thank you, Ernst.
Ну, вот как раз мы в небольшом чате с Танисом говорили по поводу сохранения. Я об этом не сказала, но как раз говорила об этом. У нас в рамках, опять-таки, региональных и федеральных программ ведется очистка рек, русел рек. И именно благодаря этой очистке, кроме того, что было использовано ил и донное отложение для удобрения полей, кроме этого была повышена, вернее, приведены в порядок водоемы для улучшения рыбохозяйственной деятельности этих водоемов. И это как раз и повышает уровень биоразнообразия, потому что водоемы возвращаются в свою природную среду. Из-за того, что было повышенное содержание ила, невозможно было, вода застаивалась, и речные водоемы превращались в болото.
So one of the projects we implemented in our municipality that had an impact on improving the biodiversity was a project about dredging the watercourses to small rivers in our municipality, and as a side effect, the sludge that was drained from the bottom was used as a fertilizer on farmland, and the effect was, and there was also an effect on biodiversity because it improved the whole environmental status of the water bodies and specifically the fish, the amount of fish in those two rivers.
То, что касается второго вопроса, я хочу сказать, что да, сейчас те части болот, которые у нас были осушены в свое время, это у нас район Вишневецкой возвышенности, и об этом будут говориться на следующих у нас семинарах в рамках программы Desire, идет обводнение этих болот.
As far as the drainage of organic soils is concerned, we have a few projects about re-wetting of the mined peatlands. The peatlands that were mined in the Soviet period are now re-wetted.
Ну, а прибрежная территория, которая находится в зоне Курского и Вишенского залива, естественно, она нуждается в осушении, и без нее, без осушительных систем невозможно будет вести сельскохозяйственные работы.
And the areas where the drainage is an essential part, is an essential living condition, are the borderlands along the coast of the Koronen and Vistula Lagoon. So there, drainage is an inevitable measure.
И как раз искусственные ветланды это будет одна из систем, так сказать, аккумулирования воды, для того, чтобы она не выходила дальше в залив, а могла аккумулироваться в каком-либо водоеме. Мы эту систему как раз рассматривали в нашем проекте. К сожалению, нам не удалось реализовать этот искусственный ветланд, но сейчас именно совместно с Калининградским мелиоратхозом мы рассматриваем другие территории, где можно было бы расположить такие искусственные ветланды для аккумуляции воды, чтобы она не просто уходила в водоем, а где-то аккумулировалась для того, чтобы ее можно было потом вторично использовать для полива.
And a brand new measure that we hope we will finally implement in the Kaliningrad region will be a construction wetland, which we tried to implement within our project, but for technical reasons we were not able to do that. But in the future, together with Kaliningrad Meliorotkhos, which considers this measure as a practical one, we hope we will be able to implement it.
И часть этих результатов как раз будет показана на семинаре 17 ноября. 17 ноября. Результатов совместно с Калининградским мелиоратхозом.
And at the workshop on the 17th of November, we will share some of the results of our joint cooperation in the framework of this project with Kaliningrad Meliorotkhos.
Я ответила?
Thank you. Thank you very much.
Yeah, thanks. So thank you for very good questions and for very good answers as well. We have to move forward. We were very optimistic in terms of timetable for this workshop, but hopefully we can manage it still somewhat close to the proposed schedule. So anyway, I'm giving the floor to Ekaterina Shalavina from Federal Scientific Agri-Engineering Center, BIM, from St. Petersburg, Russia. And she will give a presentation about the digital methods for agricultural monitoring and nutrient load management. So, Ekaterina, please.
Hello. Can you see my presentation?
Yes, you can just only go to the full screen mode. Yes.
Oh, okay.
Excellent.
Hello, colleagues. Thank you very much for time that you give me to tell about our situation in Russia and our measure that for Russia is very important because we have a lot of manure in the local places in areas. So our problem is a lot of manure in local places without area land. So priority tasks of the joint environmental activity in the Baltic region include nutrient load monitoring and development of measures aimed at its reduction. The main function of this interactive program is monitoring of livestock poultry waste management to coordinate use of organic fertilizer considering environmental and ecological data from one place to another places. The program is mainly aimed at information support for executive authorities and managers of agriculture enterprises in terms of environmental and production efficiency improvement within preparation and use of organic fertilizer in agriculture. So the first step that program fulfills the following functions. The second step, the program fulfills the following functions. The first is keeping the database and displaying the current situation in relation to agriculture organization on the map based on the following parameters: livestock, So you can see what I say in the photos. It's the screens of our program, Lushki district. Livestock enterprises focus area of agricultural lands available for organic fertilizer, applied technological solution related to manure dropping processing into organic fertilizer performances and parameters. The second is very important, that is logistics of obtained organic fertilizer use. Organic fertilizer distribution between supplying enterprises. It's enterprises that produce more fertilizer than they need for their own fields, and consuming own, so the enterprises that needs more fertilizer than they can produce, and this reporting documents drafting. Description next, that the program makes it possible to manage nutrients and to monitor the expected reduction of diffuse load provided by agriculture production in the Baltic Sea area. As a result, all produced organic fertilizer are distributed over agricultural lands. So can we see, which reduce the diffuse load in the Baltic Sea region. Biogenic elements are managed depending on specific conditions by changing optimization criteria in the fertilizer distribution logistic model. So phosphorus or nitrogen, or phosphorus and nitrogen together. We have three options in this program. Digital maps based on a selected geographic information system were used to position farms and to determine these relations in terms of organic fertilizer distribution. Such approach combines programming resources with spatial visualization and terms agriculture monitoring and biogenic load management into interactive process. Next step, so far we have developed a program for distribution of organic fertilizer for the Lushki region, then takes into account public data on soil properties. Our next steps, update and monitor the current status of agrochemical compositions of soils in this region. That is very important to apply the organic fertilizer. Update and monitor the current status of technical facilities and manure storages. Expand the program to other Baltic Sea regions, and maybe use to develop tool to organize logistics for milk and other finished products between enterprises. The digital maps based on a selected geographic information system are used to position the farms in inter-farms relationships in terms in organic fertilizer distributions. So if farmers have their relationships with our crops enterprises, we put this information in program, and the program combined this data with our logistic scheme. So at the end, we have combined real situation in this district, how to logistic all organic fertilizer. The mathematical model for limiting the nutrients introduction per 1 hectare of agricultural land was adopted as a basic criteria of a forecasting system and a logistic scheme for organic fertilizer distribution. And how I say, we have in total nitrogen and total phosphorus limiting factor of application dose, and if we put one or another factor or together, we have three situations. And effects, the first promotes diffuse load reduction in the catchment area of the Baltic Sea region, as the organic fertilizer are distributed across agricultural lands, considering the application rates for nitrogen and phosphorus. So we soil fertility increases, agriculture enterprises get plant yield. That is very important too, because it's money, and if they have more money, they can put the money for ecology. So because they have data. Risk that nitrogen or phosphorus may get to water bodies or groundwaters reduced. Due application and not storage of organic fertilizer reduce pollution emissions to atmosphere, and increased volumes of liquid organic fertilizer reduce risks of agricultural and water lodging. Thank you very much.
Great. Thank you, Ekaterina, for your presentation. Do we have any urgent question that you would like to raise for Ekaterina before we move to the last presentation of today?
I can ask a question.
Yes, please.
You mentioned some limits for phosphorus and nitrogen application. So, because normally I assume you have, if you limit the application of phosphorus to 25 kilograms per hectare from organic manure, then how do you reach the necessary application of nitrogen in that case? Because I assume it will be a problem to keep both the goals sort of and still get enough of nutrients to the crops, or do I miss? Maybe, yeah, maybe you can explain a bit.
Thank you very much for the questions. How I say we have three situations for nitrogen, phosphorus, and together, and we know how much nutrients needs for each agricultural production. So at first step we see soil, how chemical composition in this, how they say nitrogen, phosphorus, and other. Then we can calculate how nutrients we will put in this soil, that the minimum nutrients we need to the soil to put plant yield, but another limit how nutrients we will put in this soil and diffuse load, чтобы снизить I'm sorry, can I ask in Russian? Maybe my colleagues help me. У нас два лимита есть. Первый — это сколько мы должны внести минимально, чтобы получить запланированный урожай. Но с другой стороны есть верхний лимит, максимальная доза, при которой нельзя превысить, чтобы не нанести вред окружающей среде. Соответственно, дельта между азотом и фосфором рассчитывается по показателю с учетом того, сколько питательных элементов есть в почве и какой риск загрязнения окружающей среды в данном регионе, какие критерии ограничивают это внесение.
Maybe I can give some comments. We have two limits. It's one way, it's how many nitrogen needs crop production and how many nitrogen we can input on the soil before we start to make some diffuse load, nitrogen load on the water bodies. And it's mean, first of all, we make some, first limit is 170 kilogram nitrogen and 25 kilogram per hectare phosphorus. It's for general accounts. Next step, we start to look information for every fields differently.
Thank you, Eduard, for help.
Thank you.
You can write your questions if you want, and we ask for all questions in English, of course. Thank you very much.
Not ask, answer on some question.
Answer.
Okay, thank you, Ekaterina. We had one more question about approximate manure application rates, but I think that you already described that these are based on how many of each nutrient we have in manure and what are required crop requirements for each crop.
Yes, of course.
Okay, thank you for your presentation, and thank you that for all participants for still staying with us. I know that we are already after the schedule, but still, Frank, could you please present your presentation? And it seems that we will need to skip that discussion part, which we had pretty good during the presentations as well.
Yeah, will you show the presentation, or do I have to do it myself? Or?
I can do it, of course.
Okay. I can just continue from Russia to Denmark. I can see you are working with the same rules like we have in Denmark. So I think when you give a pig slurry to a field 25 or 30 tons, that's about 30 kilograms of phosphor, and then you you give it also 100 kilo in nitrogen, and then you have to apply 70 or 80 kilograms to a winter wheat. So I think we get the same rules soon, because the Danish farmer has been working with fertilizer plants and fertilizer accounts since 1992, and what's going on now is that the farmers want more environmental measures in the edge of the fields. So if you show the next slide, they got more and more demanded catch crops at their farms now, up to 30 to 50% now. So we have to find new solutions. So in 2016 we had a project where we had to try to find more measures in the edge of the fields, and we was looking at different catalogs around the world, and there was this picture from Germany. That was a guy who was working with desertification walls in New Zealand, and he said that we should look at Iowa. So we was looking at what they was doing in Iowa, and if you take the next slide, we was in US in 2016 and looking at wood chip bioreactors and saturated buffer zones, and the advisors over there told us that was the most boring environmental measures because you couldn't see them. But it can be hard to transfer a measure from one country to another, but it gave some inspiration. So if you move to the next slide, we in 2016 made a catalog with a lot of different measures in the edge of the fields. And I think that the scientists in Denmark have made a lot of catalogs, but you have to translate it to the farmers. So if you show the next slide, we try to make it very simple with some, you can see the saturated buffer zones in US look like this. And if you look at the picture down below, it's a test site we have now. You can't see anything, but that's just water running around out in the soil. And at the opposite side, you have these intelligent buffer zones, and we have some. I think we have 6 sites with intelligent buffer zones and 2 sites with saturated buffer zones now. So if you look after we have made this catalog, it's easier for people who do not want to read huge reports. It's easier to make a catalog with pictures. So if you show the next slide, after we have made the catalog, send this next slide. We have made the catalog. It was in the newspaper, and when I write the big five, it's the small measures, that is not wetlands and rewetting organic soil. So at the moment we have these constructed wetland with surface flow. We have 120 done out in the fields now, and 700 applications from the farmers. Then we have these wetlands with biofilters or wood chip bioreactors in test, and the intelligent buffer zones. They are ready to implementation, but the the wetlands with wood chips, I don't think we are completely ready to have the right construction yet. And then we have the saturated buffer zones. We don't know how they're working yet, and when we disconnect the drains, water just running out of the fields, we use them in the what do you call it, in the wetlands as a measure. But at the moment we are most working with the constructed wetlands, but I think in the future, the next 5 years, we'll have more of the other measures. So if you take the next slide, I think that was interesting that they read this catalog in the parliament. It was easier to read Donald Duck than these kind of huge scientific reports. But I think also the pictures is easier to read than a lot of text. So what I think is very important is that when we are working with these measures, that we have a good cooperation between universities, agriculture, and the Agriculture Advisory Service. And it's very important that the universities prove and approve the effect of these measures. And then I think I'm in the Danish Advisory Service, so we have to make some sales material to the farmers and advisors to show them what they could do at their field. So that's how you should see the catalog. And the next step is that you need some guidelines for the catchment officers and contractors. And then if you show the next slide, you can see you have this scientific report, then we have the sales catalog, but the guidelines how to construct them out at farm level, they are very important. So and this scientific work that show that this construction works. So it's cooperation at really many levels before you have the right setup for environmental measures, in my eyes. So what you can do, you can see the next slide. The version is now we made a new version in 2017, and we have now this year translated to English, so you can see it under WaterDrive.dk under measures. So I think that is what I'm going to say about a catalog. That was a short story. There has been a lot of struggle, I can tell you, and we are not finished yet. If the farmers not shall have catch crops overall in Denmark. So thank you.
Are there any questions from the audience?
Sorry.
I have a question. How you distribute information to the farmers, Frank, about this catalog and where they can find the information?
The first step we did with the catalog is there is a huge congress with 2,000 advisors, farmers, and researchers every year in Denmark. And there we made 2 catalogs to them, one with this small measure and one with the wetlands. Otherwise, PREZENTÄCIJAS is owned by the farmers, and we have our own website who is called Landbrugsinfo. That is all information who is done here at PREZENTÄCIJAS is on this website. So because SIGs cover all topics in agriculture. So we have this central center in Aarhus, and then we have, I think we have 20 or 25 local centers, and everything is connected in Denmark, and that information transfer is not a challenge in Denmark. It is more the funding systems that should support the measures. We have not got any support system for intelligent buffer zones yet, but it was approved, I think, 2 or 3 years ago. And it is impossible to do measures in Denmark without the scientists say yes, they work. Otherwise, it also will be a waste of money if you make a lot of measures that you don't believe in. So also for all parties that it should work. But it really needs cooperation, and it has been hard to get funding for these new measures because the world is not so simple that the scientists are thinking and then they make the measures. No, that is people who get good ideas and then they are going into tests. Where do the right idea get up? It's not in a. It can be everywhere, in the farmer's head, in a scientist's head, in the writer's head. But the approval of them is quite important, and I know that in the start that we struggled with some of the measures. They gave backwater in the drainage system. That is one of the most important things, that you don't make backwater when you are working with water. Then you get really trouble. I have done a measure by myself. Then I get the neighbor farmers, his agricultural land wet. Then you get a lot of complaints. So you need to know what you are doing. So that is why the tests of them are very important. And also 2, 3 or 5 years test of measures.
Thank you, Frank. Yeah, Zanda, please.
Yeah, I wanted to thank Frank for the explanation.
I think that Frank brought up a very, important aspect of transferring the knowledge from scientists to advisors and to farmers. And this is what also have been discussed on the EU level, how to improve this knowledge transfer from the, elaborator of this, any information to the practical user. And yes, I had a chance to participate in several events just by discussing how this knowledge transfer should be done the best ways. And I think, Frank, you showed the good examples how these transformations from scientific reports to some medium size and medium comprehensiveness materials should be transferred to the easy to read and understand practical information. So which basically what we are also aiming in this project by developing 1-pager and 4 pages for more detailed information. So maybe, Katerina, do you have any final remarks? Because I see that we don't have time for a discussion as we intended to have it, but maybe you would like to say something.
Yes, I would like to thank everyone that has contributed here, both in the presentations and in the discussions. And it seems like we have so much to talk about. So this 2.5 hours day wasn't enough. So I hope this will be more like a start of a continuing work with measures rather than the end of when we are ending WaterDrive. So I really see a need for discussions and sharing of knowledge like this. So thank you to all of you.
Okay, thank you, Katerina. And with this, I would like to end this meeting, and by also saying thank you for all the presenters and all the participants. In time, our number reduced, but we are the, how to say, the most patient or didn't plan anything after this event directly, so that we could participate till the end. It's also a good example that maybe we should plan for more time for such an interesting topics to be discussed, and it's obviously that too little time for such an interesting and needed topic to discuss. So yeah, thank you once again, and let's meet in other circumstances, in other events. Goodbye.
Bye.
Bye-bye.
Thank you very much.
Thank you, Anis. Bye.